Hello, this is our final video of F1. It's problems 45 to 58, and it's the application aspect of this section. And I'm doing problems 47 and 58. Now, keep in mind, in the book, they're a lot more wordy than what I wrote on the board here. I'm paraphrasing quite a bit. I didn't want to write the whole problem and take the whole board space just for writing the problem down. So I'll press specifically on 58 on that. But problem 47 deals with a point in the fourth quadrant, and it's 4, -3. And what we want you to do is we want to find all the points on the x-axis that are 5 units away from that point 4, -3. So if you look at 4, -3, and you go 4 to the right and 3 down, that's where it's located. Now, if you go straight up to the x-axis, the distance is 3 units. So if you're going to think about this, if you're going to get a 5-inch ruler, okay, put a 5-inch ruler, because it will be 5 units, and you try to squeeze a 5-inch ruler in here, you're not going to be able to do it. But if you tilt the ruler one way, you can find a point out here somewhere out here, that is 5 units away, because the distance straight to the x-axis is only 3 units away. So you'd have to tilt your ruler. But you're like, well, wait a minute, you can tilt it to the other side. That's right, you can. So you can tilt another one over here, and there's going to be 2 points on this axis that is 5 units away. So you're like, well, what am I going to have to do? Well, you use the distance formula. So the distance is going to be x2 minus x1 squared plus y2 minus y1 squared. So that's the distance between any 2 points on a Cartesian plane. So you're like, what are the 2 points? Well, the 2 points are going to be, one of them is 4, -3. And you're like, well, I don't know what these 2 points are, but I do know what these 2 points have in common. And that's an ordinate of 0, because that's a quadrantal point, because it's on an axis. So this point we will call x, 0. But you're like, well, wait a minute, there's going to be 2 x coordinates. There will be. So if I find the x, this actually will be represented by 2 different numbers. So the distance is 5, so what you're doing is you're going to just start putting the numbers into the formula. But in this case, you're not finding d, you know d, it's 5. So normally you would put the x's in, the y's in, and solve for d. That's what we had been doing. But this time, we already know what d is. It's 5. And so that number is 5. And then you subtract the x coordinates. Well, you know one of the x coordinates is 4. So the other x coordinate you don't know. So it's going to be x minus 4 squared. Plus the difference of the y coordinates. You know both y coordinates, because one y coordinate is 0 and the other y coordinate is -3. So if you notice, you know everything. Whoops, cracked my square. There we go. So x minus 4 squared plus 0 minus a -3 squared, and the only unknown is the x, and so that's what we're trying to find. So 5 equals, now first of all, I think what I want to do is, because I don't like the square root, so what I'm going to do is I'm going to square both sides, and that makes that number 25. But what that does for me, it gets rid of the radical. So that becomes 25 equals x minus 4 squared plus 0 plus 3 squared. So 0 minus a -3. And then what I'm going to do is I'm going to do 0 plus 3 and square it, and that's 9. So that's going to be 0 plus 3, which is 3, and squared is 9. And then we'll move the 9 to the other side. And that's 16 equals x minus 4 squared. Now, I really have a couple of choices. It depends on how strong your algebra is. You can take the square root of both sides, and then you'll get x minus 4 on the right side, because the square root canceled with the square, and the square root of 16 is 4. But you got to remember to do something. Is tack on a plus or a minus on that left side, because when you take the square root of both sides, when you square it could be a plus and it could be a minus. Nobody remembers that. So this time is one of those cases you probably just do the algebra, which means just FOIL this thing out, and it's going to be x squared minus 8x plus 16 equals 16. And so, 16. And then subtract 16 to both sides, and then you get x squared minus 8x equals 0, because the 16's canceled out. So I don't know if this is any easier, but I think most people like this way and would get the answer if they go directly this way. But you could take the square root of both sides, like I said. It just depends on where you're at in your algebra manipulation. And here you factor out the x. And so x equals 0 and x minus 8 equals 0. So x is equal to 0 and x equals 8. So those are the two locations on the x-axis that's 5 units away. Now, so that number right here is 8, 0. Now, in the previous video I said I'm not a very good artist. Well, here's the case. Notice, the other one is at x equals 0. So that's at the origin. So notice that got a little bow in it right there. So what I should have done is made it straighter. And so it's right there. So those are the two locations on the x-axis. So I got my ruler out, find the 5-inch mark, measure that distance, 5 inches, measure that distance, 5 inches. So that's how it works. So this is one of the first the applications problems that a lot of students try to stay away from if they can do them. But if you just read them a couple of times, see what they're asking, and find the appropriate formulas that you're going to use and try to picture what's going on. And that's the key, is to picture in your mind and then transferring that to paper. That's the challenge that people have. And so, but anyway, so it's at the origin and at the point 80. Those are the two that are 5 units away from the point 4, maybe 3. Now, 58. Now, again, this is a lot of paraphrasing, and the book is like, it's kind of long and wordy, and you have to read it, and you have to translate it into a picture. They're talking about a Little League baseball field, and it's a square. Most people call it a diamond, but a diamond is a square that's been rotated, and all the bases are at right angles. Okay? So, and on Little League, now it's not in baseball, but in Little League baseball, it's 60 feet from one base to another base. And what they want is how far is it from the home base, down here, where the batter's at, to the second base. So what's that distance from here to there? So you can't say 120, because that means you're finding distance from home to first and first to second. That means if the catcher runs straight from home and straight across the field to the second base, how far did he run? So what we're going to do is make a third side, and that's that dotted line is what we're looking for. And as you can see, this is just the Pythagorean theorem. So this is a right angle. So it's c squared equals a squared plus b squared. So, and that's how it works. So c is equals to, or c squared equals to 60 squared plus 60 squared. And so c squared equals to 3600 plus 3600. And so 3600 plus 3600 is 7200. And c is the square root of 7200. So that, if you break it up, it's going to be, let's see, the square root of 3600 times 2. So that's going to be 60 times the square root of 2. But again, like I said in a previous video, square root of 7200 on my calculator, get that answer, versus 60 times square root of 2. Now, in the book, they might ask you what's the distance and leave it at that. And 60 square root of 2 is probably what they're going to be having in the back of the book. But sometimes as they round it to the nearest 10th or 100th. And then you can multiply 60 times the square root of 2, or, which I prefer, is doing it this way, taking the square root of 7200. Go directly to the answer. So, but it should be about 90. It's a little less than 90 actually. Probably between 80 and 90 feet. Maybe a little closer to 90 than it is to 80. But square 7200 is about that. So again, the problem in the book is a little bit more wordy than I'm letting on here. So it's got a few more lines. But what you do is once you read it, you got to visualize this picture. And then you got to know where's home and where's for a second base. And then we're finding that distance. So you don't have to be a baseball expert to know this, but you just got to know some basic things about the game. So, but anyway, this is the last video of F1, and we'll be creating videos from every section here on out, just like we did here in F1. I'll do an overview video of the whole section, and then 2 to 3 to 4, depending on how many I need, videos per section. So some of these can be really long. It's probably some of these might be a little longer than what you would spend in a classroom. But yeah, you can fast forward and rewind as you need to. So anyway, thank you for watching.